There are a few things here I'm gonna go through. Like this presentation, when I originally thought about it back in July and August, was very much I was immersed in the parametric modeling tool that we've been working on with Volta. But since then, we've been doing a lot more work around data analysis around Alberta and Part 9 buildings. And so I was trying to find a way of like, a lot of the work that we were doing with the data was kind of aligning with what we were seeing in Volta and how we would essentially use a parametric modeling tool. So the title, if you hear just for energy modeling, there's a little bit more to it. And I think it's more of like a story. I did this presentation last week to Safety Codes Council. So yeah, I think like the vibe is a little bit different, like less safety codes like, but I think there's some things that we can learn from permitting, but also just industry also. So I see we have a lot of friends here, but like that know about us, but we also have...
We need to be holiday ready early this year, so let's start with some low price decor, like this holiday classic.
Do you believe there's already Christmas things up?
To warm neutrals. What do you think?
It's wild.
You're definitely giving maximalist.
It's like, that's the scary part.
I was feeling more classic.
Alberta is changing, and so is the way we build. Buildings are a major source of emissions, and with energy costs rising, our industry needs practical, real-world solutions.
One of the biggest challenges in industry is that we have ever-changing materials. Every building we build on the commercial side, almost everyone is unique in some capacity. And then think about all of the changing building codes and inspections that we're now throwing on buildings. So all of that complexity basically means it's more and more difficult to keep quality of a build high.
That's why Alberta Ecotrust worked with the industry to create ENBIX, an initiative that connects industry professionals, shares practical knowledge, and gives industry the tools to advance building practices across Alberta.
One of the really unique things and why we've been so happy to partner with ENBIX is they've taken a very different approach from maybe what we've seen in the past, where you had different groups with very specific singular focuses. In terms of it could be purely energy efficiency, it could be purely a whole bunch of other different things. But what ENBIX has done, I think, again, has brought that level of collaboration that just I've never seen in this space.
Construction associations often represent sort of the commercial side and build is residential. We're not always in the same room together, so ENBIX can help be that connective tissue between us. And then also brings together, municipalities or other knowledge that's coming from other jurisdictions. So there's a huge role to be played in bringing that sustainability knowledge and making it so that we're like all working sort of on the same team as we do that, and just making sure we're all aware of what everyone else is doing and leveraging that information.
Those conversations weren't happening a decade ago. While there was really well-intentioned people, really well-intentioned kind of groups focused on trying to advance high-performing homes, there just wasn't that collaboration to bring in the real-world challenges that exist when you're trying to build these homes. And then by really bringing those real-world challenges to the forefront, you're then actually able to figure out real-world solutions.
If you work in building, construction, renovation, or any related field, ENBIX is your go-to hub. Head to enbix.ca to get started.
All right, that was our hype video. Oh, this guy see it. Yeah, so this is one of the sessions that ENBIX is sponsored at BuildX, and so as you heard, like one of our biggest missions is to go through and collaborate with different people in industry. But one of the main things I think for me is just trying to daylight a lot of the work that's already happening, and that's part of what I'm going to be talking about today is like the work that's happening in Alberta that has happened, some of the tools and resources that are out there, trying to guide people to where you can find those. So I know there's not a lot of us in here today, but I try to make this a little bit interactive, so there'll be a few spots where you'll be able to interact, and it might not work on us now, yeah. So in terms of like who's in the crowd today, there'll be like 3 or 4 of these, so you could put this up, just getting feel, or we can put like hands up, there's not a lot of us here. But in terms of engineers, architects we're looking at, or like do we have builders, do you have municipalities in the crowd? Just do you have your phone ready, and These should pop up here. And this is a big thing for us. And I try to put a lot of these in our presentations because it really helps understand of like who we're giving like the different messages to, if there's people that we are missing that we need to target. But also it's like as the questions come up through these sessions, it's like what is the lens that they're coming through on our end as well. How many people are in here? So we have like 10. Once they get like at least 50% of the people up there, we'll go on. Yes, great. So for those that don't know, I guess, more of details about ENBIX, it was created basically to look at some of the conversations that were happening like 5-6 years ago, back when there were city charters. Was like, what would it take to look at looking at different levels of tiers and code with the larger municipalities? And in the conversations that we had with industry, one of the big things was, we need resources to get there. We need to have like training, case studies, and just like a bit more know-how of what it means to get to these different tiers. So, you look to BC where you have Zeek and Zebex, or, it's also started in New York and then eventually actually started originally in Brussels, I believe, with like what they were doing at Passive House there. But having that center where you bring industry together and start sharing as much information as you can. And so that is shaping the exchange. A lot of conversations happen with industry and just kind of get a feel for what ENBIX needed to be. Our funders are City of Calgary, City of Edmonton, Government of Canada, so Intercan, LC3, FCM, Peter Gilligan Foundation, and the RBC Foundation. We have events calendars. As I mentioned, is trying to show what's already happening in the industry and across Alberta. It's trying to have a central repository of where you can find different things that are happening around Alberta when it comes to energy efficiency and emissions reductions. If you haven't signed up, I suggest you do, and you can see there's something every week, it seems, happening in Alberta. Our resource library continually being updated. The one thing that we look at when all our work in ENBIX is this Alberta lens. So like not only are we like daylighting all the resources and tools that are in Alberta, but it's what is applicable to Alberta. And I'll touch a little bit on that, like what that means. But what we heard was, what we're hearing coming out of BC or coming out of Toronto doesn't seem as applicable in Alberta. I heard that from builders and different professionals, and really was, okay, well, what are the solutions here? What are some of the things that have worked already? And we could, again, daylight some of those. So you can find those in a resource library where you'll eventually be able to find the modeling tool that we will be publishing here in the next few weeks. CLF, so we talk emission neutral buildings. We also talk about embodied carbon. We've partnered with CLF to essentially start looking at not only obviously the operational, but also the embodied and what that life cycle looks like. So trying to look at buildings and those emissions from beginning to end while they're being operated. So into the presentation. So this is, as I mentioned, there was, I was going through this and really thinking about like why we created this tool. It kind of brought me back to 2016, early days. Younger Juan was at the City of Edmonton and in charge of implementing the energy code for the permitting group. So 2016, Cubs win the World Series. Pokemon Go was the rage. Batman and Superman, this one actually annoys me sometimes because Superman dies in it, and I don't think that should happen. And Donald Trump inaugurated for the first time. So interactive time. 2016, what's something that stands out for you, whether it's personally or even industry-wise? Yeah, I think it's like that kind of like inflection point of energy code coming to Alberta and being basically like felt like the front lines of what the builders were thinking, what they were worried about, and trying to essentially like navigate what it meant to meet energy code. 936, yeah, exactly. That's mine, 2016 also. Is anybody else typing? There's a few typers. Fort McMurray wildfires. It was May 2016? Yeah. Paris Agreement ratified, yeah. My 2016, I became a dad. This is Ines, and she's a firecracker, and obviously needs to be by the fire truck. So a big part from my end, and like personally, but the rest of my 2016 was creating forms for permitting, and looking at the prescriptive path, what that meant when builders would be applying for permits, what it meant when they came through on the performance path, and what kind of documentation and when it would be needed in permitting. And I'm saying all this is just because as I think about the modeling and all the data that we're getting, there was these foundations that we put in, and now like looking back on it, where are some of the things that we get close some more gaps when we look at higher levels of energy performance. And a lot of this is part 9. Basically, this whole presentation is going to be mostly part 9. As we get into the part 3 work, it shifts a little bit. So somebody who I worked with very closely at the City of Edmonton was a safety code officer that had been there for quite a long time, like very, very knowledgeable, very long-winded, but just because he knew so much, David Flanagan. But I remember one of the first sessions we had with industry when there was a lot of worry of just what it was that was going to be needed for 936. And this quote that came out was like, most of you have been doing most of this most of the time. And it was true. And I think the main thing that we were asking at that point was, we just need to see it on drawings now to confirm that the actual energy code is being met. And a lot of that was just kind of the way that permitting happens and how it is reviewed on the plans exam side versus the inspection side, trying to like essentially get like the bigger risk items before it goes out and gets built, because as much as we talk about permitting timelines and how long it takes, there is that balance of risk, right? Like if you're not catching this thing at the beginning, you go to the end and the inspectors go out and inspect it, and you're further down the line, then the cost of fixing it during construction is a lot cheaper, let's say in some cases, than doing it before it's actually built. So in 2016, code comes out, and it is, I'm just going to move this here. Still has minimum requirements. The code's always been seen, I think it's like, there's like the code in general has been seen as prescriptive. However, it's been objective-based for a long time, and I think that's something that in the conversations we had to safety codes last week, they're trying to lean into, is like, what is the intent of those code articles? And when Energy Code came out, there's 3 different ways. There was a prescriptive, trade-off, and performance. And performance was essentially that kind of like built-in variance where you don't have to meet the minimum for all the different items, but you look at the building as a system. And so the new terminology came out with that. So what was a reference house? What's a proposed house? What does this reference house look like? Why is there a fictitious reference house? Effective R value was a big thing. Like we were always talking just about what the bats were in the studs. Blower door test, what does that mean? What does it look like? Air tightness, getting an understanding of like how you measure that air tightness, and energy modeling. And I'm biased just because I've have history with energy modeling, but to me, when I think about the energy modeling and just the power it has of going through, one, for energy efficiency, but also just efficiency in design and construction and how we can use it to make better decisions. It was one thing that we really had to go through and almost like demystify, really. And I think the hard part of that was looking at that reference house. We always got caught up on that reference house, and were things actually being modeled, and people weren't trying to cheat the system, which was another kind of hurdle that we had to get through. So this was like the first inspections that I went out and did with the team, just to get, like how are things going, like why are things failing, showing pictures to builders and kind of showing like what the fail is and kind of comparing that to like what the code is asking for. And the biggest one really came to like air barrier and just having that structural backing on penetrations. And I have a ridiculous amount of pictures of that in my Google Drive. And it really is, you look at the steel one, or sorry, like the metal one there, and that was everywhere. And it was being failed at least twice a day, I would say. And so it was like trying to figure out, okay, well, as we're looking at kind of these fails, how do we look at that with the risk mitigation lens that we were also doing for the rest of the code? And like what's important when it comes to energy performance. One of my colleagues, Justin at SAIT, has recently been doing like, these conversations with the city of Calgary of like what is important during plans exam, what is important during inspections. You know, where would you see the most heat loss? Where does like, and where are those big energy gains and losses? And you know, when I look at it, and you know, coming from envelope like performance first, it was air changes. So that's something that we really looked at. We provided a lot of information to builders on how to get there, what those solutions were. And the hard part with code, when you look at this, is there's that risk of designing and also the liability, or like the assumed liability that comes with providing the answer to builders, because it could be seen as like, well, you know, safety codes officer told me to do this, something happens to the house later on, and it comes back to that safety codes officer, and it's just this circle of litigation. It's something that you know, continues to go through in the system, and like how do we all look at that risk and who bears that risk. So all that to say, it's we started off with air barrier, and really that was kind of like the first bit at the city of Edmonton. Some of them were getting better at it, so they would like get the one with the flange on them. Others would actually, you know, do partially backed, and then there was this whole blue tuck tape debacle that happened because there was a lot of red tuck tape at the time, and blue was the one that was needed for vapor barrier. So yeah, a lot of different changes coming in, like, and small ones. I think that were, I think the level of detail that we were inspecting at that time, in some cases, like I was saying, like we probably were looking at the most important ones. And where was it that we needed to focus our time on the inspections for timing, but also thinking about like the quality of these builds. So I mentioned building as a system, and this is something I think like, you know, you come to your BuildX and you usually hear this a lot. You hear it, you know, as you're designing, you're consulting energy models. There's a few energy models in here, and looking at that building as a system. And because all the different items in the code have been, you know, separate for so long, energy modeling and the energy code really brought them all together. And I think, and there were some instances where that was missed. You know, things like insulating hot water lines. There was always arguments around that. I was like, why do we do that? The amount of energy that you're, you know, going to be saving by doing that is not that much, so it shouldn't be that big of a deal. Insulation under radiant heated floors, also very similar, like the cost of doing that compared to like the amount of energy that you'll be saving. Again, is it worth it? And that one we actually saw stand data come out where radiant, insulation under radiant floors isn't needed. But then you get into the conversation with municipal affairs, like if we do that for every single item, then technically nothing in the code matters based on like the cost and just the amount of savings you get, like let's say per R value in your wall. At what point do you start cutting some of those things out? So we really have to keep on looking at building a system and keep it all intact. We started looking at HRVs, what that meant, how it impacted the type of walls that we'd be putting in with the higher or lower R values on there, window U values, and like the quantity of windows that we were seeing. I think the first few months, all of the windows were triple glazed, just because of the fear of that you needed to have like really great performing windows. And I think that lasted for a little bit, and they shortly started seeing like, well, you know, the cost of that, and like we don't actually need to have that triple glazed window to even hit the prescriptive route. But I think still there was always HVAC to save the day. Those that would start doing energy modeling, and that had been doing it for a while and started doing it shortly after the code came in. You started seeing more of the energy modeling and getting a feel of like where they can optimize like the cost and meeting the requirements for code. I'm not going to too detailed into all these codes. I'm talking about the future ones as well, but like May 2024, new code comes in, and now there's more ways to the meet energy code. There's a tiered code. There is a prescriptive tier 1 way to meet the code. And I think about that and just like what we're seeing with those codes coming out and like all those different options. Obviously, Enercan is going through and doing a lot of energy modeling in the background to get to those. But it really goes against what we hear and like what we want to do and have creativity almost when it comes to energy efficiency and be able to model to find what that balance is and where some of those solutions are. Whereas if you're doing the prescriptive tiered one, it's very specific on like what you're gonna do to get there. And I think some builders need that, and I think depending on the jurisdiction that you're in, speaking to some EAs yesterday from the Red Deer areas, like in the rural areas, you really just need to know exactly what to do, as opposed to going through and doing energy modeling, understanding what happens when you go through the energy model. We're gonna see where that prescriptive portion comes in. There's changes to air tightness that have happened in the reference building and the proposed, so without going too much detail into that. The furnace efficiencies have increased, so now, HVAC to save the day is getting a little bit harder to do that. And then looking at like the testing, when you do the testing, the type of testing. So the code has, I think, done a really quick jump already from like where we are at right now in Alberta with Tier 1. And what the next jump will be, it's are we ready for it? And that's a little bit of what I'll be showing here. So yeah, of course, the tiers, for those that aren't familiar with them, I think a lot of people in this room are. We're at Tier 1. Tier 2 doesn't seem as much of a jump there. We're seeing the Tier 3, Tier 4, Tier 5, and like you get those Tier 4, Tier 5s, it's like that net zero ready. But yeah, I think it's like, is there a way to get to like that net zero or emission neutral if you're still at Tier 3? And I think that's something that I would be interested in seeing and what that means. But the building envelope improvement is that one push now to look at more of those passive strategies and like, again, having that envelope that's going to last longer than the mechanical systems or, leave it there. So this was my inspections 2 weeks ago at the City of Edmonton. And everything's looking a lot better. And also I was actually quite surprised as I was going through and going through with the inspectors on these, just to see not a lot has changed in terms of the general construction and the assembly of the buildings. It's aside from looking at basically adhesive everywhere, everything looks a lot more airtight right now. And a lot of those buildings were coming in basically at Tier 2 already of the 6 buildings we saw that day. Without, again, doing a lot. I think it was mostly insulation in the basement and probably in the roof and an HRV. All right, interaction time, because I know codes are riveting. So for those here, I guess it's like, is there, do you want to share a secret to getting to better energy efficiency? I've had a conversation with other, with people, and it's been more on the commercial side, but it's like, how do you, in some cases, can you like sneak in energy efficiency? It's like, is there something that doesn't look like energy efficiency, but like builders, customers, tenants, homeowners want that? And what does that look like within the industry? I don't know if there's any answers to that. I'd be interested in hearing that. Heat pumps. Scandalous. Oh, good one. Occupant behavior, yeah. Yeah, I think that the occupant behavior is like, it's a really interesting one. And like going back to the HRV of, you have that HRV in and they're wondering why this unit is running the whole time, and so they'll turn it off. And the whole point is for it to be on. I think it's something that we talk a lot about and seems to come up quite a bit. Also, like the heat pumps is an interesting one, and I'm probably going to put Cooper on the spot here at the end of this presentation. for a question. District energy, really good one as well. Yeah. I bumped into the director of the Blatchford District Energy System at my hotel yesterday, and they're expanding their district energy to downtown Edmonton. And so it was interesting just to see, like, obviously the one in Blatchford, I'm digressing here. The one in Blatchford is through GeoExchange, and the one downtown is natural gas. It's like, what does that look like now when you're trying to offset the emissions? And I think, you know, as I'm going to talk to you a little bit here, is like what, for the next code, when you're looking at emissions and efficiency, how does that kind of change the narrative with what we're seeing so far in Alberta for performance? So kind of the same way I went and talked about the code, I want to talk a little bit about the tools that came out around that time. One really great one, actually, that came out in 2016 was the CHBA Illustrated Guide, very similar to the one that came out in BC when Step Code came out, and was really able to go through and show prescriptively like what the code was meaning and saying, and visually to see that, and even had some wall assemblies in there that helped out for the builders in the beginning. Our effective calculators as well. One that I really like, and I think is pretty cool, is like the LEAP sessions that Intercan does. This one is actually for a home in Calgary last year, I believe. And so, you know, obviously having the cost also, and all the different inputs, so you're able to go through and publicly get a feel of like, if you're changing all these things, and it's hard to know like what the assumptions were for this one, but you can start kind of breaking out like per cost and like energy savings wise, kind of ballpark of where some of these things and what the impacts are of them in Alberta. Speaking of my colleague in Red Deer earlier, has put together something based on like, you know, what has been happening in Saskatchewan. So Saskatchewan was at Tier 2 from the onset. They're actually looking at going to Tier 3. I thought it was the beginning of this year. Pulled it all the way back to Tier 1 prescriptive, but there's costs associated with that. And so different EAs across the province are like, you know, getting creative of like, what does it mean to get to these different tiers, or even Tier 1, going through energy modeling, and like there is cost savings to be had, and there's also just like a more efficient way to build both energy-wise, but also just like construction material-wise as well. And another plug for us, if you are at the trade show today and you stop by our booth, we have our retrofit tool, so you can go through and pick out commercial buildings, get like a high-level desktop energy audit assessment, and then one of our coaches can work through with that data and connect you with our vendor alliance that we have across the province as well for retrofits of commercial Part 3 buildings. Okay. I said codes was a little bit dry, but data, I guess, could be dry. However, when I want data, I want all of it. And so we've been seeing a lot of it, and with our partners in the municipalities, and also through Intercan, we'd be able to kind of start getting a good idea of where Alberta is right now with the Part 9 construction. This is the City of Edmonton data pre-2024, May 2024. And we try to break out essentially kind of where, so the bottom is basically each line is a home. And you can see kind of like where the energy performance is for those. This is about 15% of all of the applications. So yeah, obviously a lot of Tier 1. You started seeing a little bit more of that Tier 2 pop up, and then there's like that little peak there of Tier 3. And then in terms of how they are applying, there's the performance around prescriptive, so performance really doing like almost 75% of all the applications. To our friends here in Calgary, same, the data in 2023, what does that look like? Again, each line kind of showing each application, and you can see kind of like the breakdown there of like where that kind of Tier 1 comes in, and Tier 2, and then after that, it's like just that little bit of Tier 3. So we looked at that, and then we took all of the open data from NRCan from Alberta for all the ERS models, and started looking at the 2023 CMHC housing data. Those were single detached, and 2024, and how many of those models and labels we had. Sorry, excuse me. So based on that, it's 2023 is about 28% had done a ERS label model, and 2024 is 27%. And I somewhat of a Malcolm Gladwell fan, so like when I think about like tipping points, and you hear about like what are those tipping points to like really kind of get a larger movement, and 30% is kind of like a magic number for different kinds of movements. And to me, it's like we are close just to getting the labeling. But to get to the next tiers, I'll go into a little bit of that, but the next part of this presentation is really just more of where are we at? We're closer than we think we are, and like what's the other nudge we need to get there. And so this is how it's broken down per tier. So we took all of those and tried to get a feel of where those are at. So you can see there's a lot of tier 2. Majority were tier 3. Not surprising, those that are looking for a ERS model and label, you would think they would put more value on energy efficiency. So as we look at this data, how do we include that with the rest of the Alberta data that we are going to be producing in the next few months? So 20% of the new construction were at tier 3, 22% are tier 3 and up. So that leads us to this project I'm alluding to. So, excuse me. The Volta modeling project was really to provide a tool for builders, designers, even trades, let's say, to get a feel of what it would take to get to higher levels of energy efficiency. But as we were building that up and we were working on the code data, on the code readiness data project, we were starting seeing like we could use some of that data to help inform what the inputs are, and which ones would be like more of most value, and I think help give that little bit of that nudge. So we started looking at Hot 2000 reports. We worked with the city of Edmonton. Essentially, they created like this really intense OCR tool that can pull data from all the Hot 2000 reports. We looked at 9.36 summary tables that are provided for all permits, and we started looking through about 10 to 15% of all of those. We've done that for Edmonton and Canmore now, looking with some information from Calgary soon. The idea is for next year is to have it all roll up for all the municipalities, as many as we can, and show where Alberta is and kind of show what the different pockets are, and almost like how homes are being built in all those pockets in Alberta. So for City of Edmonton, this is the data that we have now. The newest is there's still a lot of tier 1. There's a 23% that's coming in at tier 2, and then just that little sliver of tier 3, no tier 4, and just like another sliver of tier 5. And then what we did is, because we had all that data, we started looking at what the walls were at each tier. And the Edmonton data is really surprising because the walls don't get better. But then not surprising when I went out to site and I looked at the walls and they weren't any better, and they were at tier 2. So we looked at the walls, so you can see kind of the spread there. The median is still, it's higher in the tier 2 than it was for tier 3, which we still are going to go through with our consultant to try and understand that. The roof gets a little bit better as you go up the tiers. The windows kind of stay the same. In tier 3, they went up a little bit, and as we're going through some of those, is just trying to understand like why that window ended up being higher. But then the one in the tier 3 one is a little weird. I think there was this 1 or 2 that had a different air change. Everything comes in at 2.5. So when you come in for the permit, there's no incentive to go through and have a tighter building. On the permitting side, what does that look like and why? Adds to a bit of uncertainty. There's that risk there. and it could add additional time because now you're doing the blower door, and if you don't hit that number at the end, then you're coming back and trying to hit that and send that back to the city to show that you actually met that air change. So to me, when I look at this, it's like that's one big place that could be an easy win. I think somebody put air tightness there in terms of energy efficiency. Then we look at the heating systems, and that's kind of like you start seeing like that heating trying to come here and save the day. They're getting a bit more efficient. I think less than 1% of the ones we saw had heat pumps. So all this right now is based just like on furnaces. And domestic hot water, looks like that's what they're using there to make up some of their savings. So that's Edmonton. When we look at Canmore has a policy where they, I think through development permits, are asking to get to Tier 2, but also have a label as well. When you look at Canmore, there is no Tier 1, which makes sense. But there's also not that much Tier 2 compared to Tier 3. And that was the interesting part, and I'll go through it, is just kind of how we're analyzing and trying to like understand a bit more of what's happening there. So a lot of Tier 3, there's Tier 4, and you're seeing that Tier 5 there right now in Canmore. The walls are good, you know, like the Tier 2 is already at 3.26. You're looking at like the medians there, that's similar, like about 3.5, and they just go up and up as you go up the tiers. So when I look at this data compared to like the one we saw in Edmonton, there's something there that just hasn't aligned yet for me in Edmonton. The roofs get better. And this one was a great one because this data is all from Enerchem because they're all the ERS models. So you could see the Tier 2s are at that 2.5, and then it gets lower and lower as you're getting into like the higher tiers. The heating systems also, like everything is just getting better and better. And there's one thing, I think, what I'm thinking of when we're looking at this data right now is it a factor of builders and even just like, and the trades and everybody together just almost being worried about not hitting that Tier 2? If it is, I mean, that policy is working. But the other part of it is, do we not trust how good we are at building airtight buildings, right? Because I look at those walls and they keep on getting better, which is great. But once they're going through and doing the blower door test, are those Tier 2s being bumped into Tier 3 because they don't realize how much more savings they're going to get as they're building a tighter home? So that's something we're going to work through with the town of Canmore. But also, it's with all of this data, is how do we start focusing on like those easy wins? And through all this information, it's starting to become evident that like air tightness is, and I don't know if like, I think probably preaching to the choir here, but like it is that easy win. It's just a matter of process-wise, what does that look like for industry? So the conversations we had was like, how does that help? How does this data help with permitting processes and inspections? By working with this data with the municipalities, safety codes and builders, where can we find some of the things and just show that with these numbers, like these are the things that will have the biggest impact, and like what is the cost for those now if that's something that we want to focus on? How do we keep that permitting and inspections moving at the same pace or faster? And what are those high-risk items to look for based on the data that we're getting now, and knowing like where the energy is coming and going? We haven't gone into heat pumps yet, and that's the one thing. I think there was some in the Canmore ones, but yeah, I think it's as we get into heat pumps and getting the additional savings from those. How does that now impact the air changes or even the walls? You know, talk about this. The house as a system, how will we use that, I guess? It's like, are we going to use it to still have the mechanical systems save the day, or are we going to go through and have those more energy efficient envelopes? Okay, after we had got all of that data, we created this. So this is the energy modeling tool that we have we had Volta create for us. And the intent was, and like some of the background on this was seeing what had been done in BC during step code, and it was very similar, I think a little bit more colorful. They still have some of these target finders there. But again, try make one for Alberta and what we're seeing in Alberta. So we have all the inputs on the left-hand side, and then we have the outputs on the right-hand side with the to be able to go through and put a slider and change those. So this is going to be a little bit awkward, but I'm going to try to get into here. This is our landing page. So this is our landing page. Right now, the archetypes that we've started with are the single detached with a garage, duplex / row, so really just semi, and semis with garage. Starting with something kind of like easier and hoping to go through and get more row houses on this. Does it have a basement or not? You select that. Which climate zone is it in? Put the HDDs, and our comms team quickly told us they should probably say where they are in Alberta, because not everybody's going to know HDDs. So let's say we go 7A. And then we get to window-to-wall ratios, and some of these, like, we started looking at just the front and the rear faces, because as we talked with Build, Alberta and Calgary and Edmonton, because of a lot of the zero lot line work, there's not a lot of those windows on the side, so we're really just focused on the front and back, and being able to adjust those. Just basically, I think one's 15, and then you can like ramp it up to 30, which is quite a bit. Once you click that, it'll go through and do all of the runs, and you get this. So the top, it gives you an idea of like what you selected, and you can see the inputs that we have there. Those were based on the data that we looked at from all the permitting. So we looked at like what the typical was, what some of the ones in tier 3 were, what some of the ones in tier 4 were, and spread them out that way. So it was something that is already happening in the industry. Same thing for the walls. For the walls, the nice touch we put there, I guess like the little surprise, I guess, was we included 2 of the walls that you'll see downstairs on the trade show floor. So the ENBIX walls, similar performance, so you could select those from there, but also like the walls that are happening now, and kind of like, again, the tier 3 and 4 wall, or mostly the tier 3 wall that we saw there, which is also downstairs, close to, it's like that, basically the regular wall with the additional like 1 inch of foam insulation on the side. Went into exposed floors. We have the windows there. Windows was the kind of the hardest one that we had to put in. Again, all this coming from the data that we got from the cities. Air changes, heating, ventilation, domestic hot water. So as we're going through, you could start off, if you want to look at just energy savings, and you can start that slider. Oh, I can't see. There you go. And you go front, put all your inputs in, or you work backwards and get a feel for what you want to do for energy efficiency. The idea here is trying to reduce the barrier on builders and designers, or even like, this time of year, a lot of the home designers are looking at the next model of houses that they're looking at for next year or the year after that. Can they use a tool like this that's like really high level, just to get a feel of how some of the decisions they make impact energy efficiency? And as they start to kind of like provide more detail, narrow in on what those models will be like, send those to an EA to make sure that they're actually meeting those requirements. You can see capital cost at the very end there is 0. That is purposeful. Anytime I've done any work with cost, and I do policy work or just a larger report, I'm always told it's wrong, or it's it's off. And in a time where costs are consistently changing, what we decided to do was leave that up to like the builder, designer, to be able to input their own costs. So for each one of those inputs on the left, they could put a cost there. It'd be like you basically have to put like the full cost for like that design. Eventually, all those costs would populate, and you'd have the different capital cost. You'd probably choose what the lowest one is, and then what the energy performance is, and it kind of give you an idea of what the design should kind of look like, and you could keep on tinkering with that. And then the back end of that is, once all those costs are in, they could go and select one of those lines, and it's a line item below, and they email it to themselves, they email it to their EA, they show what the package is, and at the end, they're able to say, hey, would you mind giving us your costing data? Based on that, like, is it, very detailed? Or is it a high-level estimate? And so that helps us understand like those numbers that we're seeing. Also, they just be like random numbers in there. So that's kind of like the next step of like our data project is aligning the costs that we're seeing through this tool and with the data that we're getting from the city as well. Sorry, this is awkward. And as you're going through, you can, again, kind of clear the selection. The intent, again, is just to reduce that risk. We keep on hearing of builders, designers don't know where to start, even though there's many great people in this province that can help out with that. What's the one thing that they can do just to get understanding themselves of what those different energy decisions do to their designs. This is our first take at it. It's going to be coming out in 2 weeks, so I hope everybody will have a chance to go through and work through it. If you know any costs, put them in, please. But yeah, it's really like, with all the work that we're doing now at ENBIX and through Alberta, a lot of it's now starting to align, and many projects are kind of overlapping. And there's other things that are happening in Alberta with different consultants that this overlaps with, and so we're just trying to bring a lot of that in to, just have basically that one place that helps out, but also send people to the other talent that we have in Alberta. I don't know if that was anticlimactic, just all that data, and then the model is there at the end. So what's next? The new code in 2025, or new code 2025, new metrics. So looking at energy use intensity, GHG, with the air tightness metrics. 2030, like embodied carbon coming in, and the conversations with Build Calgary and Build Edmonton. We're talking about getting to tier 1 here, tier 2. And then we start throwing in the embodied carbon. It is something that we need to focus on, but it's how do we, get more confident in like what we're building now in terms of energy efficiency. And when I look at the data, I think we're getting there, and I think that story isn't being told enough, both on like the builder side, the trade side. The organizations, the municipality, like safety codes officers. When I put this up, and one of the questions I had for them was, what is the barrier for you when you're inspecting something? And it was knowledge, which is unfortunate. For us, it really solidifies like where we need to focus our efforts with that training. But the other thing that came up was just like having the tools and like tools that they can trust. So that's the intent of this, and like this is all open source, and we welcome people to work with us. And if there's things that that will make it better, we really love to hear about that. Retrofitting the energy code, and do we start seeing incentives for higher levels of code in tiers, both in the commercial and the residential scale? So I talked about the Alberta lens that we use, and it's one like I always like to make sure that we talk about it, and it's out there. I grew up in rural Alberta, went to Vancouver for like 10 years and did consulting there, and I really drank like the Passive House Kool-Aid. And I still fully believe in all of that, but I think getting back to Alberta, it was hearing about, like the cost and affordability and the speed, and even just like how we build homes here. It's different in Alberta, and it took me a while to really understand it. And as I've been going through and looking at even at this data, a lot of the builders are actually like, most of you have been doing most of this most of the time, and they're doing it and they don't know that they're doing it. And I think there's a story for us to tell that like we're on our way there. And when you talk about the costs and adding additional costs, that's your baseline already. Like tier 2 is your baseline, and you don't even know it yet. And it might even be tier 3 because you're not even doing blower door testing. So there's more of that story that I think that we all collectively have to tell. And I feel like with this data, and also like having this tool help out of where, like, how do you get to that next step? And it's not that big of a leap. We have that, that can do in Alberta. So it's, we're special for that can do. Everybody talks energy in Alberta. I was in a talk yesterday. They were saying like the most engineers per capita in Canada. We have an interesting regulatory environment. Things, trying to open things up so you could do as much as you can, but also in some cases we're not pushing the things that we need to be pushing, is going to be the way I'm going to say that. Solar potential, like the solar potential that we have in Canada, in Alberta, when compared to Vancouver and the work that they do there, there's so much more that we can do here with renewables. Our climate obviously always comes up. In our grid, and I think that's one thing. When I go to Ottawa and we do like the building decarbonization conversations, we talk about fully electrifying, and completely agree. But I think there's different like hybrid solutions in Alberta that work as well. It is like we talk about these steps to get to emission neutral and net zero. And to me, like the one thing that came up for heat pumps, like there's an electrifying, there's still like that step, that step of that hybrid heat pump system, just to get through that change management of getting people used to having a heat pump, really, and just that comfort of that natural gas. Same thing we're seeing with the data already is like slowly seeing people get comfortable with building just that tiny bit better, and then eventually kind of give that bigger push, especially as we see the new codes come out. So that's why I think we are special in Alberta. And I think the tool is like one thing to help us to give to those builders, the people that are just interested on like what energy efficiency is, what energy modeling is. It's still like, this one is like a black box. So it's really giving what the what the assumptions are, but starting to move all of us forward in that conversation of that building as a system, and then what the Alberta solution is, and allowing people to have open access to those tools and the data as well. And that is it. You could ask questions. My slides did not change there. It's okay, there's only 2 anyways. Thank you for coming. I didn't get to show, I took this picture on a walk in Edmonton, so I unfortunately didn't get to see it, so I needed to show it to you. So there it is. You could pop questions up here. You could ask questions. We got a question?
Yeah, I was going to say, given the audience, if we could just ask. So I'm Luke Killam. I'm with Green Key Energy, which is my own company. We do energy consulting. We've got a homes division, and what we do is we go in and consult with homeowners that are interested in solar but don't know how to get the right system for their needs without getting ripped off effectively. One of the things I find, though, is that it's really hard, and this is a bit it seems really hard for, to get homeowners interested in the idea of energy efficiency. What do you see as being a way that you could unlock that, incentivize, entice people? It just seems like it's something that for the majority of homeowners, it's not something they think about or see really value in.
This is Juan Monterosa's opinion. To me, it's like energy labeling for homes, for commercial buildings. It's it's like having the gas mileage on the cars, right? And so it's by having a metric that all homeowners see or know about, and they could compare other homes, and they could, like whether you use the lettering system or like a number or something just to make it easier of where their home is compared to like other homes. Then you start putting that value on energy efficiency, because like then you look at like, oh, my home actually like isn't like, it's beautiful, but like it's super leaky, and so I use a lot of energy, and like then you start thinking of like how do I make my house like the biggest purchase I'm going to make better, because I've invested so much in it already, but like operationally and maybe like quality wise, it's like it's not that great. So to me, I think it's labeling, and it's just like it's that almost like there's the education piece, but like the labeling really drives like to me like the demand for people to ask for better.
Yeah, I can just add something to that. The labeling is, like Juan said, the house is a really big investment people make. It's typically the biggest investment people make in their lives, and they take it sight unseen by the person who built it. There's no third-party evaluation. You wouldn't buy, like most people don't buy a car and not know the mileage, not care about it, but they don't know the mileage. Like they'll know it, somebody will tell them.
Yeah.
They'll know the safety ratings of it. We don't do those things for homes.
Yeah.
And then to the labeling point, any energized home that meets tier 2, so 20% better, is automatically a single form submission to CMHC will meet a 25% mortgage insurance premium reduction, which can be $3,000 for many people. And it's a single form, and a $250 blower door test by Parametric.
Yeah, and that's like new construction and like retrofits, and that's to me like that's the beauty of it. Like there's a system that exists out there now, and that's just the labeling. And mine, because just like my code background was like, there's tiers out there right now, and when anybody gets their home, they're like, this is like the best home because it meets code. It's like, no, that is like the minimum requirement without breaking the law, right?
It's the worst home.
It's literally the worst home you could do because you just met the minimum. So there's the 5 tiers. So if people could speak code, it would be there's tier 1 to tier 5, and like this home is a tier 1, that home is a tier 3. Like, will the homeowner then pay if there's the additional to get to that tier 3? We got 1 minute.
Who do you see being the primary user base for your tool?
Home builders and like their design teams and like their like drafters. This would be the main one. We've had a lot of conversations of like what it means like in the real estate market, right? Not that they're going to go through it and design it, but like just to know like what energy modeling looks like. But like for actual use, it would be home builders. Okay, 11:30. Thank you, everybody.